Yeah. Hi, I'm Yuhan Xiao, and I'm first-year student from College of Information and working with Sarnisa Katsuri. And I'm really lucky to have my slides showing here for about 10 minutes. So I'm excited to introduce this work about bridging the deaf and hard of hearing live streamers and hearing audience in the context of e-commerce live streaming. And this research was conducted when I did my master's in China with co-authors Zhihao Yao, Meiyu Hu, and Qianyao Xu, and is published in CHI 2025 late-breaking work. This work is built on a social phenomenon where deaf and hard of hearing individuals are increasingly participating as live streamers in China e-commerce live streaming. And they sell products through live streaming to make a living. And about e-commerce live streaming itself, it generally follows a structured flow with well-prepared scripts. But at the same time, live streamers need to stay flexible as both product sales and performance and audience live comments vary in real time. So during the live streaming, most DHH live streamers use sign language, which naturally attracts the DHH audience. But the relatively small population limits their sale. So to get larger earning potentials, they hope to reach the hearing audience, but face obstacles in the communication, like the hearing audience cannot understand the sign language. At the same time, the virtual live streamer has gained popularity in the market. Like some e-shop owners started to use this kind of avatar to sell their products 24 hours a day on a live streaming platform to make a profit. However, with the influence and success of the virtual live streamers, little research has linked them to people with disabilities, especially in the DHH live streaming area. So we started to think about whether the virtual live streamer could support DHH live streamers and collaborate with them in selling product to the hearing audience. So targeting this question, our work started by interviewing both DHH live streamers and hearing audience to deeply understand the communication challenges in sign language e-commerce live streaming. And we found that beyond hearing audience cannot understand sign language, there are several more challenges that from both information and emotional aspects. And here I would like to introduce about the emotion challenges and the corresponding design for the virtual co-presenter in the presentation. And for more findings, I recommend you to check out our papers published in CHI 2025 extended abstract. So one noticeable challenge here in emotional expression is that hearing audience may misinterpret the positive emotions of hearing live streamers as negative ones due to the different understanding of body language and facial expression. Like in sign language, facial expression is very essential to convey tone and intensity. However, some hearing audience may misread this kind of expression. For example, hearing audience interpreted their enthusiastic signing as aggressive and says they had exaggerated facial expression, seems like they are arguing. And even in some case that they correctly identify the emotion, they often lack of context to resonate with it. For example, another hearing audience noted, I could sense their excitement, but I didn't know why, it just felt odd to me. So all these factors constructed the misalignment of emotion between these two communities in sign language live streaming. Based on the interviews, we then held a design workshop with 6 designers to create the virtual co-presenter, and it is designed based on well-prepared scripts and aims to collaborate with the DHH live streamer in live streaming to help hearing audience better understand and engage. So to address the emotional gap from the interviews, the designer created a cartoon virtual co-presenter. And they used a cartoon-style animation because it effectively convey emotions that hearing audience are familiar with and help them to better understand the feeling of DHH live streamers aim to express. And besides the style, they also incorporate some e-commerce gesture in the animation. For example, these gestures were inspired by popular hearing live streamers and were picked for being the most recognizable one for the hearing audience. For example, here, the animation of putting up a link is a countdown before the product goes on sale. And this gesture paired with go for it encouraged hearing audience purchase at the key moment. So after finishing the virtual co-presenter demo, we evaluated and received some design suggestions. I will mention 2 about the emotional part. First, The hearing audience wanted animation with more promotional phrases to create a feeling of urgency, like limited quantities available or today's lowest price, as one of the hearing audience mentioned. These short animations can also support flexible needs during the live streaming. Also, DHH Live Streamer provides suggestions on characters' appearance to better express the emotions. For example, one DHH Live Streamer hoped could convey joy and closeness, as well as including some DHH elements like hearing aids. In conclusion, we understand the challenge in sign language e-commerce live streaming and propose a virtual co-presenter as a potential solution. And we are now refining the system based on the design suggestions and evaluating it in real-world live streaming. So if you are interested in this work, you can check out our paper. And I would like to thank my advisor, Hanisa, for giving advice when I revised this work, and other colleagues for giving me feedback. And thank you.
Hello everyone, I am Nupur Wagle, a graduate student and a researcher at the College of Information. My work focuses on designing more inclusive and usable digital experiences for older adults. Today I'll be sharing insights from a systematic literature review that I've been working on, where we've looked at how existing technologies can be augmented to support learnability and usability for older adults. So let me begin by telling you how all of our work started. My father is nearing his 70s, and I often find him staring at his phone, frustrated, irritated, unable to figure out where to click, how to get a task done. I see him swipe back and forth and tap random buttons to see what happens, and sometimes call me for help, or other times give up altogether. And I'm sure many of you in the audience have faced or observed something like this. And we realize that many older adults struggle with everyday technology. And it is not because they're not trying, but it is because systems weren't designed with them in mind. So this experience got us thinking, are researchers trying to solve for this? How are they trying to make technology easier for older adults? What methods are they using? We found a lot of guidelines and great lists of what to consider, but we were curious about what concrete strategies people were already trying. So we asked, are there ways to support learning and usability without redesigning everything from scratch? Which got us to our research questions. What we're trying to understand is strategies or design patterns that researchers have used to add information or cues to interfaces. We're exploring what stage of development these research papers are in, how they've implemented the strategy or design pattern, like what kind of technology they're trying to support the use of. And after designing the research questions or arriving at the research questions, doing a literature review seemed like the obvious first step. We wanted to see what researchers have already done to make existing technology more accessible by adding layers of guidance, not by building new technology. Because redoing every system isn't practical, we wanted to find actionable design approaches that could scale. So what we did is we followed the Prisma method for our review. We searched the ACM digital library using combination of terms like older adults, learnability, support, tutorials, and so on. And after screening 245 papers, we selected 26 that met our criteria. All of these were studies that added layers to existing technology to improve usability for older adults. And now I'm going to share the preliminary findings of the paper with you. Our project is still work in progress, so these are just preliminary findings. We have contextual overlays as one of the methods where information is shown using text or images with examples like a ghost hand and text overlays. These act as visual cues and help navigate through an app. There are step-by-step guidance where there can be a voice or avatar-led walkthroughs. There is error-tolerant exploration, features like undo modes and try again prompts, and search space reduction, where systems are narrowing down choices or direct user attention. So what we've learned is most solutions support momentary task completion and not a broader skill development. One of the patterns we saw across many papers is that support is being offered is often designed for the moment, where they have contextual tooltips or a step-by-step prompt that walks you through specific tasks. And these are helpful for someone for the task they're doing right now, but they don't often contribute to a broader understanding of the interface or help older adults build the skills to handle future variations or updates. So in most designs, most design solutions solve how do I do this right now, but do not help figure out what I can do the next time. The other thing we saw was social scaffolding, something like using peer support or videos or share walkthroughs. This appeared in a few papers, but what they'd done really stood out. And one other thing we noticed is how many interventions are one-time tutorials or reactive aids. But what about helping older adults develop a sense of confidence so that they feel empowered to explore, troubleshoot, or grow their tech fluency over time? So we've noticed that there is a need for a shift from quick fixes to scaffold learning experiences that not only assist, but also teach and reinforce independence. We are currently analyzing the remaining research questions, including what technologies are supported and how far these projects are developed. Our next goal is to synthesize clear, transferable design recommendations for inclusive technology. So what we've seen is that you don't always need to start from scratch to make technology more usable for older adults. A lot of value can come from smart, well-placed layers of support things like a voice prompt or a helpful overlay or a friendly guide. The key isn't to reinvent the wheel, but it is to give people a better roadmap. Thank you.
Hi everyone, welcome to my presentation focusing on AAC and quality of life. I'm Ruo Tonggang. I'm a first-year PhD here at Info College. So I would like to show my thanks to all my collaborators first, like including Claire, Lei, and my advisor Stephanie, and all other people on their valuable feedback on this work. So maybe let's get started with what AAC is and why this research matters. So AAC stands for Augmentative and Alternative Communication. It refers to a broad range of strategies and technologies that support communication for people with speech-related disabilities. So this includes things like communication boards, speech-generating devices, and specialized apps. So this work is deeply inspired by conversation within the AAC user community. As you can see here, like many AAC users have voiced a significant gap between academic research and their lived experience. In particular, they asked, despite all the new technologies being developed, how much of it's actually improving their quality of life? So this leads to the central question of this research. How can HCI research better support the quality of life of AAC users given the current technological advancement? To take a step back, let's consider where this gap comes from. So today we have many innovative technologies, computer interfaces such as tablets, brain computer interfaces, and XR systems that offer new ways for people to communicate. This tool shows technical promise, but when it comes to real-life communication or real-life context like making friends, participating in work, or just leisure activities, it's still unclear how these technologies can really help AAC users to in their interpersonal communication and alternatively improve their quality of life. So to address this question, we conduct a systematic literature review looking at both HCI and clinical studies on AAC creation and usage. We grounded our analysis on quality of life framework, which is developed by Sherlock and Alonso, which identifies 3 key dimensions: well-being, social participation, and independence. We then applied a semantic analysis to identify key patterns and gaps. So our findings suggest that while many studies focus on improving technical performance, such as speed, accuracy, or device usability, there is far less emphasis on how AAC tools function within real-world social contexts. So based on this, we identified several opportunities for future AAC research and design. These include improving social accessibility of AAC devices so that it can be used more comfortably in public and group settings. Supporting relationship building and handling beyond just transactional communication, which is also very emphasized in the AAC user community. And also enhancing user control and self-determination, especially in terms of personalization and voice selection. So our particular interest is on interdependence, which is a dimension often overlooked in current quality of life frameworks. We found consistent patterns across studies showing that AAC communication is often not done in isolation. For example, if you are imagining you are communicating with another, you cannot doing this only by your own device. So thus, their communication are usually supported by communication partners, such as caregivers, family members, or peers. They play an active role in shaping the success of AAC media communication. So this means that we are not focusing on communication as the only burden on AAC users, but it's also about relational dynamics, environmental and interpersonal factors like how a conversation partner responds or whether the setting is accessible can significantly affect the outcome. So as a result of this study, we argue that for future AAC research should not only aim to support independence, but also to enhance and design for interdependence. That includes like community-based practices that reflect real communication experiences. And also, ultimately, our goal is to center the lived experience of AAC users in research and design so that technology not only function well, but actually enhance well-being, social participation, and autonomy in meaningful ways. Thank you all for listening, and I'm happy to take any questions later.
All right, so back to what I was saying. So this is a proposed study I've been working on this past year. It's called, I'm sorry, let me rephrase, AI-powered tools for AAC users to communicate intent effectively. So this work wouldn't have been possible without my mentorship that I received from Dr. Stephanie Valencia, and also collaborative efforts from my lab mate, Rotong Gao. So this study mainly focuses on using AI tools to help AAC users communicate their intent effectively, as AAC users tend to experience barriers in communication, such as delayed timing when communicating their thoughts, as well as difficulty with topic maintenance. So just to give a brief background, to build off of what Rotong was saying about AAC users include alternative communication methods used to help individuals who are nonverbal to express their wants and needs. So they come in various, various designs. So we have low tech, which consists of more paper-based AAC, and then we have high-tech devices, which is a tablet that includes icons to express their wants and needs. So just to kind of go back on the communication barriers discussed, they access these devices through various ways. So they access them through touching their screens, eye gaze, and also switches. So despite these diverse access methods, some challenges still remain. So when typing a message as an AAC user, it can take several minutes to form a response, whether it's using the keyboard on their device or using icons to form their message. It does take away from the conversation. It creates that barrier between themselves and the communication partner. Also, issues experienced include topic maintenance. They tend to get distracted and only focus on what they're typing, which can take them away from the conversation topic, and it also increases the cognitive burden. So how do we mitigate these challenges? So my proposed solution, based on previous work, is using large language models to help improve AAC communication. So previous work has shown that large language models have been used to provide alternative phrases, which can reduce time constraints. Also notifying communication partners when the AAC user is typing, and also providing word prediction based on limited utterances. So similar as if you were typing on your phone and you see iMessage provides like 3 or 4 words to use. It's very similar to what an AAC user has, because it helps them expand their utterances and make their communication more, more efficient. So some of the research questions I'm hoping to explore during this study is to explore how AAC users and caregivers co-create prompts for LLM use. So I've been looking to kind of build on this study by focusing more on the relationship between the caregivers and the AAC users and building something like this, because caregivers play such a vital role in AAC communication, and that they're their predominant communication partner, and also help with communication support during the conversation. And then some of the other questions I hope to explore are the benefits and challenges of using LLMs for supporting communication, and also the feasibility of of using an LLM for a communication tool from the AAC users and SLP's perspective. So I recently conducted a speech language pathologist support group to gather some perspective on using ChatGPT for communication for AAC users. So some of the insights I've gathered were using ChatGPT for intervention activities, rephrasing goals, and also forming parent emails. Then for the workshop itself, I hope to recruit 4 to 5 adult AAC users and have them create physical and digital prompts. So some of the physical prompts include taking three blocks and having them answer who, what, and how questions to identify the context of the prompt. Then those 3 words are inputted into ChatGPT to help generate a phrase they could use in a conversation. So the anticipated outcome of this study, I'm hoping to explore more of ChatGPT's role in conversation, as well as its potential to mitigate communication challenges experienced by AAC users. I'm hoping to build on this research by exploring other populations. So there's also not just regular AAC users, who may have complex needs, or also AAC users who may be autistic. So I'm hoping to see how that differs, and also explore more the relationship between the caregiver and the AAC user when designing these prompts. And that's it.
Thanks, Claire.
Good morning, everyone. Or is it almost good afternoon? So, good afternoon, everyone. My name is Abhinav, and I'm here to talk about approaches, features to improve color contrast in designing documents. So this is collaborative work with Adobe Research and Adobe Express. I'd like to thank Alexa, Rajiv, Jose, MJ, Yalpi, Rick, Gareth, and my advisor, Dr. Jonathan Lazar. The focus of our group has been on designing and making digital documents more accessible for people with disabilities. Right? So we've built the Ali tool, which focuses on applying accessibility markup to headings, reading order, tables, image alternative text. Right? We also built the Formally tool, which makes editable PDF forms more accessible. Right? We all use forms for taxes, reimbursements, contracts, and several annoying things. Right? Right now, so the focus of the Ali and Formally tools, they used a repair and remediate approach. Right? They took an approach in that documents could be repaired for accessibility after they have been created. But current work, our current focus is on making documents born accessible. How can we make documents accessible during the process of authoring? Make it very, very easy. So, how many of you were here at the symposium last year? All right. Okay, that's awesome. So if you don't remember, that's okay. My beautiful hair was much shorter back then. So last year I presented on image alt text and text tagging. Today's talk, we're going to focus on color contrast. Right. So there's 300 million people across the globe who have some kind of color vision deficiency. That's about 4 to 5% of the world's population. if you trust my math. People have red-green color vision deficiencies. People have blue-yellow color vision deficiencies. Right? And not only that, designers, when creating documents, they have to face a bundle of drawbacks, a bundle of challenges while trying to make documents accessible. Right? There's a lack of awareness on best practices in making documents accessible. Right? There are tool shortcomings. And quite importantly, quite often designers have to navigate the challenge of making a document accessible while making it aesthetically appealing. Right? So meeting contrast guidelines like WCAG, our solution is to provide proactive, born accessible recommendations to help add accessibility markup and make documents more accessible on the fly. Right? So I have some prototypes that I'd like to show you. I believe everybody likes prototypes. So let's say I have this canvas. Let's say a user is creating this design, various shades of hue and blue text in the middle. Right? And on the top, we have, I think I should come outside. So on the top, we have an accessibility icon, which denotes that there is a contrast issue in the center. And on the left side, we have a bundle of suggestive recommendations in solid text color, text with outlines, and then solid backgrounds. Right? 2 minutes left. Time flies in good company. So, if I take any one of these suggestions, then I can make this text more readable and improve the contrast immediately. Right? So the contrast is fixed. The aesthetics are not compromised. Right? But let's say if I have another example, I have 3 pieces of blue text here. I add one more text. I have one more text. I now have 5 accessibility errors here to fix. So if I click on, let's say I have one more, I'm labeling this hill here. I'm calling it Alp because it's very, very high. And if I click on this panel, then I can click on any one of these suggestions and I can fix a bulk of these issues at once. Click auto fix. And a number of text elements have now attained higher contrast and readability. Right? Very, very lazy way to fix benefits of born accessibility. Right? So we've conducted 2 user studies, a survey with 40 authors and an interview with 8 designers. And we've obtained a bundle of feedback across various image types with complex backgrounds, image, gradient, and textured backgrounds. And we noticed that the performance of text color varies across the various intervention types. And of course, there is always a challenge, there's always a tension between navigating how to make a document more readable while trying to achieve an aesthetically and visually pleasing document. Right? So I'm very grateful to be pursuing this work as an intern with Adobe right now. And the next step is to integrate these features into the Adobe Express product and evaluate designers' workflow while trying to test out these features. So thank you all so much for listening. If folks would like to talk about color, find me and we can have a chat.
Baron.
Hello, thanks. So I'm going to be talking about photosensitive epilepsy and some of the work that we're working on trying to make safer video and tools that people can use to make safer videos. So what is photosensitive epilepsy? It's a reflex epilepsy. So it's something that occurs and they can't have any control over it. It's triggered by specific visual stimuli, so often flashes, oscillations, vibrations, flicker, those kinds of things. It can also be triggered by bold stripe-like patterns, so just viewing these kinds of patterns. Some publications talk about it affecting up to 1 in 4,000 people. So it's not extremely rare, it's not extremely common, but it is something that does occur in the population. It's most common in adolescence, and it's discovered generally then. It's about twice as common in females than it is in males. And of people who have epilepsy, about 3% of them also have photosensitive epilepsy, where they would respond to flashing and other things like that. So, there are some guidelines out there. A lot of these were created in the late 90s, early 2000s. There are 5 of them of note. 3 of them are international. One is from just the UK and one is from Japan. None of these are fully harmonized, so there's some differences between them and some nuances. But some commonalities is that all 3 characteristics must fail simultaneously to be considered hazardous. So it needs to be intense enough. This flash needs to be either intense in luminance, so its brightness, or it needs to be a red flash that changes colors. It needs to have a large enough area, and it needs to have a sufficient flash count or rate. And I'll talk about these a little bit more. So the intensity side of things. So for luminance flashes, this is where there's a threshold difference in luminance in each of the standards, and it's how different the brightness is. And so as the luminance change increases, the hazard potentially increases. Red flashes are a different type of flash, and one state must be a saturated red, and there's a threshold difference in color, or chromaticity actually, between the 2 states. And so something that's, say, blinking red to orange is not as hazardous as something that has a larger chromaticity difference, say red to blue. Red to blue, just as an example, was the flashing that occurred in the Pokemon episode that some of you may have heard about, that sent about 700 children in Japan to the hospital back in the late 90s. Area is another part of this. There's a threshold area. Larger areas that you view stimulate a larger portion of the brain, and so that can cause a seizure. So a larger area on the screen, of course, increases the hazard, but also sitting closer to it increases the hazard. So viewing on a television that's far away may be safer than looking at your laptop or a larger screen closer to you. And then there's also a flash count. And so all of the standards have different flash count thresholds. One of them that's very common is 3 flashes per second. And so up there I have a chart which displays patient responses to flashing and flashing at different flash rates. And so you see kind of the safe bar, if you will, is that little green bar that relatively few people respond to flashes that are under 3 flashes per second. So this is all fine and good that we have these standards, but we also need tools. And so developers need ways of testing their algorithms if they're trying to make tools to actually to do these kinds of screenings. Video publishers and platforms need these screening tools, and they need these to be able to run really efficiently. And finally, content creators need friendly tools that can flag where the problems are so that it's easier to go ahead and fix them. So that's what we're working on. We currently have a tool. It's kind of an aging tool. We call it PEAT, the Photosensitive Epilepsy Analysis Tool. It's aging, and it can't be made open source, and so that's something that we're building from the ground up, is a tool that will be open source and will be kind of a gold standard, in that we'll do a pixel by pixel level analysis, and then the hope is to extend that with algorithms that can be more efficient in the future. We're also working on tools for generating benchmark videos, so we need to have ground truth videos that can test the algorithms and things like that. And so we have tools for generating those videos, and then a set of benchmark videos that other developers and folks can use. And so for more details, papers, and other things, and I just want to thank you for your time.